Our next video is going to be about solving differential equations, kind of in the simplest case, just to review some differential equations you've seen before in Calc 2. So these are what are called separable differential equations, and we're really just looking at them as an example to kind of illustrate some points about differential equations. Okay? So a separable differential equation is one where you can move all x's to one side and all t's to the other. Okay? And this is called separating a differential equation. So if you've got a differential equation like dx dt equals xt, this is separable because you can move the x over to the other side by dividing 1 over x. The t stays over here. You could move the dt over to the other side by multiplying. And so if you move all the x's over here, you've got 1 over x dx. All the t's over here, you've got t dt. And so that's separating. And if you remember from Calc 2, we do separating and then we do integrating. So integrate 1 over x dx, integrate t dt. 1 over x dx gets you ln of x plus c. Integral of t dt gets you t squared over 2 plus some constant. And since we've got two different constants here, if you think about it, you've got some constant you don't know here, some constant you don't know here. There's no real reason to write them both on opposite sides of the equation. We could just put them all together. We could move this one over and kind of fold it into that. And that's what we generally do. And then our last step, we separate, we integrate, and then we can solve for x. And of course, to solve for x here, you exponentiate both sides. And so we get x equals e to the t squared over 2 plus c. Okay? Now, e to the t squared over 2 plus c is called the general solution, e to the t squared over 2 plus c. Or x equals e to the t squared over 2 plus c. Let me be exact. X equals e to the t squared over 2 plus c is called the general solution of this differential equation. If you have an initial value, if in addition to the differential equation, you're also given something like x of 0 equals e, right, some initial value, these two together are called an initial value problem. It's what we usually see in a mathematical model because we know that, for example, like it fits this particular pattern and we know where it's starting, right? And so that's generally what we're going to see. If you've got an initial value, you can solve this. You can say when t equals 0, x equals e. So e equals e to the 0 squared over 2 plus c. So e equals e to the c. So c equals 1. And you get x equals e to the t squared over 2 plus 1, which is called a particular solution. Okay? So in general, a differential equation will have a general solution. The differential equation along with a particular value, initial value, will give you a particular solution. Okay? So let's talk about some other separable differential equations. A lot of differential equations we really like are separable. So one, if you've got a recurrence relation, a differential equation now in the continuous sense that looks like this, dx dt equals rx, so the change is some constant multiple of what was there before. If you think about what this gives us, this is our exponential equation. So this is exponential growth because it's growing by a fixed percentage of what was previously there before. If you separate and integrate, you can solve this pretty easily and get the classic exponential model that we're very used to. Okay? So solving that gives you x equals some constant times e to the RT. Okay? So that's easy enough. Other models that we've seen before, though, are also separable. So dx dt equals rx 1 minus x over k. So this should look familiar. We did a lot of modeling with this when we were talking about discrete models. This is the logistic equation. Okay? You can see this is also separable. It doesn't have any t's at all over here, so you can separate it completely by moving everything over to the other side and solving. And you can go through and solve this. This one's a lot harder to do, so this one's pretty easy. The integrals are not bad. If you do this one, it involves partial fractions. It involves a lot of different kinds of it involves partial fractions, substitution. It's a lot of fun. You could try and separate and integrate this one if you want to. But eventually you'll get x equals, I think it's k over 1 minus e to the negative rt plus c, I think, is the logistic solution that you get from separating and integrating this. But again, the point being that these differential equations, ones that we've already seen before a lot, are separable. And so they're actually relatively easy to solve, even with the techniques that we already have. Okay? In the next lecture, we'll talk about linear differential equations, another set that are actually fairly easy to solve.